Hey guys, this is Mr. Grice for Algebra 1, Unit 4.1 Notes. Today we're going to be talking about solving and graphing one-step inequalities. Our learning target today is to be able to solve and graph single-step inequalities involving addition or subtraction. Now, you guys might be like, whoa, Mr. Grice, what are we talking about? Well, let me show you. So far, all we've talked about are problems like this. Like, oh, dude, that's so easy. All you gotta do is subtract 3 and x equals 1, Mr. Grice. Well, good job. You're correct. And that has one answer to it. What we're going to be doing now are problems like this. Okay? And you're doing the same stuff. Well, hey, I got to subtract by 3 to cancel that out. But now x is less than 1. Well, less than 1. Aren't there a ton of numbers less than 1? Well, yeah, just look on a number line. Here's 1. Is 0 less than 1? Is -1? Is -2? Is 2? Is 3? So what we're going to be talking about today is how to graph and how to show that. Okay? So, a couple things that you need to know when you're graphing inequalities. The variable must always be on the left side of the inequality symbol. Okay? It's always got to be on the left side. No ifs, ands, or buts. And each graph should contain at least 5 integers. Okay, and that's kind of like what we just did where I had the 1 and then I picked 2 numbers above it and 2 numbers below it. Okay? So, the symbols you guys should already know. Okay? You should know what less than is the symbol that you can make with your left hand. Okay? So when you have the is less than symbol, you need to shade to the left, and then it's going to have a special point, and it's called an open point. Okay. Now, if it's is less than or equal to, we're doing the same thing where we shade to the left, but this is what's going to be called a closed point, or one that you shade in. Okay. If it's greater than, we're going to shade to the right, and it's going to be open point. Okay, and is greater than or equal to, we're going to shade to the right, but this time it's going to be a closed point. Okay, now open or closed, that's when it's closed, and then if it's like that, that's when it's open. Okay, and then the symbol, which direction it's pointing, tells you to shade to the left or shade to the right. Okay, so every time we do this, we should be asking ourselves, what kind of point do I have? Is it open or closed? And then which way do we shade? To the left or to the right? So let's go through this. For number 1, is it open or closed? Well, it's open. And then are we going to shade to the right or to the left? To the left. So we're going to draw this ourselves. And 2 is where we start. Okay? And I have to go 2 numbers to the right and 2 numbers to the left. So it's like we keep counting. 2 plus 1, well, 2 plus 1 is 3. 3 plus 1 is 4. Okay, see how we're just continuing the pattern? And if we go to the left, we subtract 1. So 2 minus 1 is 1. 1 minus 1 is 0. Okay? And now comes the fun part. So it's an open point, so I'm going to draw an open circle, and we shade to the left. Notice how I did that. I clearly noted that I shaded to the left. I don't want to see any weenie lines that look like, well, here's my line, here's 2, and then you go like that. One, I can't tell if that's open or closed. I want you to really make it obvious for me. Okay? I'm getting old. I can't see. Neither can Miss Carranza. Don't tell her I said that though. Okay? Make it very obvious. Okay, let's look at number 2. Is it open or closed? It's closed. And the variable is on the left, which is good. So do we shade to the right or to the left? We shade to the right. So let's draw our number line. I start at -3. So what's -3 plus 1? Well, -3 plus 1 is -2. -2 plus 1 is -1. And then we just continue the pattern. Okay? Now, at -3, we said that it is closed. And then we shade to the right. Why don't you guys try number 3 all on your own? Pause the video and good luck. Okay, for number 3, it's closed and it's to the left. Okay. Let's scroll on down. Now, number 4. Well, number 4, where's my variable? The variable's on the right. I don't want that. I want my variable on the left. Okay, so what we're going to do is we're going to rewrite it, and x, so we have x and -3. Okay, so this is where we're rewriting it. Now, 2 ways you can think about it. Who is it pointing at? Well, if it's pointing at the -3, I want to make sure it stays pointing at the -3. Okay. Another way people have learned it is little Pac-Man eats the bigger number. And in this case, it's going to eat the x, so I want to make sure on the other side, Pac-Man's still eating the x, okay? It's whatever way you guys like it better. I'm always going to say who it points at, because that makes more sense to me, okay? So since it points to the right, okay, is it open or closed? Well, it's open, and then I shade to the right. So I got -3. I go 2 above and 2 below, so I just add 1. And then we subtract 1. It's open, and I shade to the right. Okay? And I'm drawing my arrows even when I'm shading, so I know that that keeps going. Okay? All right, the next one. My variable's on the wrong side, so I want to rewrite that. So we've got m and 5/2. Which way is it pointing? Well, it's pointing to the left, okay? So it's pointing at the m. So I'm going to make sure that it's pointing to the M. All right, and this is closed, and we shade to the left. Now, the only problem with this is, well, what's 5 over 2? Okay, if you don't know what 5 over 2 is, divide it, okay, and you get 2.5. All right, now, when we graph this, we're graphing integers. I'm not graphing decimals, okay? So when we graph this, my numbers are the integers, but 2.5, well, where does 2.5 fall? In the middle of 2 and 3, and it's a closed circle. So there we go. And then we shade to the left. Okay, does that make sense? All right, why don't you try 6 all on your own? Pause the video and good luck. Okay, so the first thing I did was I had to rewrite it. It was pointing at the inequality was pointing at the 0, so I made sure it stayed pointing at the 0 when I flipped it. It's closed and to the right, so then that's what I drew. Okay. All right. Now we have to go backwards. They gave us a graph, and we have to draw it. You can pick any variable you want to, whatever the first variable you think of in your mind. Okay? I'm going to go with the G. Now, we have to ask ourselves the same questions looking at the point. Is it open or closed? Okay, it's closed, and we shade to the right. So if it's closed, when I draw this, I have to make sure that there's a line underneath it, and I shade to the right. All right, and then we started at -5. Why don't you try number 8? Go ahead and pause the video. Good luck. Now remember, you guys could have picked any variable. It doesn't matter. But you got to ask yourself, is it open or closed? And it's open, and we shade to the left. So open and to the left is the less than symbol, and it's less than 4. All right, moving on down. Solving one-step inequalities. Now, we have to follow the inverse order of operations when solving, okay? And that is SADMAP, okay? When we're solving using SADMAP. Okay, this is what we do. We always check for addition or subtraction first. Then we're checking for division or multiplication. Then we check for exponents. And then the last thing we would do is worry about the parentheses, okay? And now this is the biggest thing right here, guys. You cannot forget this. If you ever multiply or divide by a negative, anytime, you must flip the inequality. You have to. It's a rule. Like, Mr. Grice, that rule's stupid. Okay, well, I'm going to prove you wrong right now. So let's take a look at this example right here. -2x is less than 4. Well, if you were to solve this, you have division, or you have multiplication. To get rid of multiplication, we divide. Be like, I'm not going to flip it. So I'm just going to write here, no flip, because we didn't flip it. And we get x is less than -2. Okay. So if x is less than -2, there's our number line. It's less than, so it's open and to the left. We can pick any number to the left, any number, and let's plug it in. I think in class we used the number -5. So this is our check. Well, what's -2 times -5? Well, -2 times -5 is 10. Is 10 less than 4? No, it's not. This is a false statement. Okay? So even though we just did everything right, we did not flip the sign. Okay? And so let's do it the other way. So -2x is less than 4. Doing it the right way, you divide both sides by -2, and you get x, and 4 divided by -2 is 2. And the key thing here is you have to flip that sign. And once you flip it, we pretty much have the exact opposite graph. Okay? We're still open, but now we shade to the right. And we can pick any number to the right. Okay? Let's pick 0 because it's right there. -2 times 0, is that less than 4? Well, -2 times 0 is 0. And is 0 less than 4? Yep, it's true. We're happy. So you got to remember to flip the sign only, guys, only because we saw some kids doing this for everything when you multiply or divide by a negative. All right, let's do some examples together. It says solve and graph the following inequalities. So there's my variable. It's on the left. To get rid of the x, I'm going to subtract. I did not multiply or divide, so my symbol stays the same. And 2 minus 6 is -4. So -4, I go 2 numbers greater and 2 numbers less. Remember, if you still need to think, be like, okay, well, it's closed and we shade to the left. So it's closed and we shade to the left. There we go. Okay. Number 10. To get the m by itself, hey m, where are you? I'm right here. It's on the right side. We have to add 2 to both sides. And I get -1 is less than m. So right away, I want to rewrite that. Okay? I'm going to bring it down right below it. So when we rewrite that, I want the m and then the -1. Now, who's it pointing at? Is it pointing to the right or is it pointing to the left? Or is it pointing at the m or the -1? I'm sorry. It's pointing at the -1. Okay? So all we did is rewrite. We didn't multiply or divide, so that's why it stays like that. Okay? So -1, 0, 1, -2, -3. Is it opened or closed? It's open, and we shade to the right. So open, and I shade to the right. Okay, number 11. How do we get the W by itself? Well, we divide. Now, was it by a negative? No, we're dividing by a positive. So if we're dividing by a positive, it stays. Okay? And then all we have to do is go into the graph. Is it open or closed? It's open. And do we shade to the right or to the left? To the right. Okay? Let's go ahead and flip it over. Why don't you guys try number 12 and try number 13 for me, okay? Go ahead and pause the video and good luck. Okay, there are your two ones. And just remember on number 13, we had to rewrite it because the variable was on the right. So that's why we switched right there. Okay, that was a rewrite. All right, let's talk about 14. When you look at 14, what does it have? Well, 12 is less than or equal to n minus a negative 7, okay? So if you have n minus a negative 7, we've got two symbols right there. And so if we've got two symbols, we don't do that anymore, guys. You got to simplify that, okay? So that's really saying n plus 7, okay? And now with n plus 7, now we just solve. We subtract the 7 to both sides, and we get 5 is less than or equal to n. Our variable is on the right, so we have to rewrite that. Who's it pointing to? The right? Is it pointing to the 5 or is it pointing to the n? Okay, it's pointing to the 5, so I want to make sure that it's pointing to the 5. Okay, let's go ahead and graph. We got 5, 6, 7, and then 4 and 3. Okay, is it open or closed? It's closed, and we shade to the right. Okay. All right, guys, we're just going to do 3 more of these. I know that there are a lot, but we're only going to do a couple more. And let's look at number 16. Okay, so 16, we have multiplication. How do you get rid of multiplication? By division, and we divide by a negative 4. So if I'm dividing by a negative 4, I have to flip that sign, okay? And then negative 32 divided by negative 4 is a positive 8. And then we go straight into our graph. Up. Sorry. 8, 9, 10, 7, 6. Is it opened or closed? Okay, it's open. And do we shade to the right or to the left? We shade to the left. All right, number 18. What's going on to the x right there? Well, remember that means division, and the opposite of division is multiplication. So we have to multiply both sides, and we get x is less than or equal to 4. So is it opened or closed? It's closed, and we shade to the left. All right, last one is going to be number 19. So with number 19, it's being multiplied by a fraction. And to get rid of a fraction, we have to multiply by the reciprocal, okay? So I need to multiply both sides by negative 3 over 2. Now, we're multiplying by a negative, which means I have to switch that sign. And then 6 times negative 3 is negative 18, and negative 18 divided by 2 is negative 9. And you guys should just be doing that in your calculator if you can't do it in your head. Okay? So now that we've got that, we can do the graph. Is it open or closed? It's open. And do we shade to the left? Okay, guys, that's it. If you need more help, you need to come and find either Ms. Carranza or myself. We would love to help you out. We know this is difficult because we're learning a new section. Okay? Well, guys, that's it for Algebra 1 Unit 4.1 notes. Thanks for watching.